Hi, my name is Mohammed, and today me and my group members, Sobi, Zurain, and Omar, will be talking about Michael Jordan's legendary free throw dunk. And in case if you haven't seen it, here's a clip of Michael Jordan's free throw line dunk. The reason we're covering this topic is because of all of our general interest in the sport of basketball. As kids, we were amazed by athletes such as Kobe, LeBron, and Michael Jordan, and we were amazed by their freakish athletic abilities, and we wanted to know what it took for them to do what they did in the sport of basketball. We are interested in how a man could take flight so high, and while many others after him could not do the same. So in this video, we'll be talking about the physics behind his dunk, how many forces were present, like such as Newton's first law. In addition to all the forces present, we'll also be talking about Jordan's hang time, and through a formula we learned in class, and we'll discuss how he was able to do that.
Before MJ began his dunk, we have to analyze the forces present acting on him which contributed to the dunk. Coefficient of friction was great enough to prevent MJ from slipping. His shoe sole was made of rubber and polyurethane, which is the common material used in basketball shoes now. These materials have a high coefficient of friction, and that leads to a lot of traction, which helps the player gain more velocity and increase his vertical height. To start, we will be discussing the free body diagram that helps explain how Michael Jordan could achieve his free throw dunk. We know the formula for force of gravity is mass times gravity. So given that, we found the force of gravity experienced on Michael Jordan to be 971 newtons. Now that we found the force of gravity, now we can find the force of friction. Since we know that Fg is equal to Fn, since he's on a surface, force of friction is equal to the coefficient of friction times the normal force. And in this case, the coefficient of friction on a hardwood surface is around 0.67. So by calculating the value, we found it to be 650 newtons. Friction is one of the most important forces since an athlete needs to be able to change direction and leap at any moment. Now that we discussed the components of the forces in a free body diagram of the free throw dunk, I will be discussing how Newton's third law applies to this scenario. Newton's third law states that every action has an equal and or opposite reaction force, and in this case, MJ generated power from his whole body and applied it to the ground, thus the ground applying it back on him and allowing him to jump into the air.
Okay, we will now figure out Jordan's hang time and height through a formula that models hang time. Before we start, we first have to understand this graph. So a basketball player can jump as high as 4 feet in the air vertically, and the higher he jumps, the greater hang time, which is the total time he's airborne, and the greater the time he will appear suspended in midair through the high point of the jump. Typically, there is a horizontal and vertical component in the jump velocity at takeoff. The magnitude of the vertical component and of the velocity at takeoff will determine the time the player spends airborne, since gravity acts in the vertical direction and will act on the player to bring him back down. Thus, the vertical component of velocity after takeoff will change the time. The figure below shows the typical trajectory a basketball player might travel as he makes a jump. You can visually see that almost half the hang time is near the top of the arc. Using some mathematics, one can calculate the time spent in the top part of the jump, and from there we can figure out how high did he jump. So Michael Jordan's dunk represents a parabola, and from there we can figure out what time it is. Our variables we needed velocity, gravity, and its angle. The velocity was 4.5 meters per second. Gravity acceleration was 9.81 meters per second, and approximately his angle that formed was 80 degrees. So to find time, our formula is T equals to 2v sine theta over g. So if we sub into our variables in, we can conclude that his hang time was 0.91 seconds. So once we figure out the time, we can now figure out the height. So the formula of the height is height equals to v squared sine squared theta over 2g. We sub in our variables. So from there, we can conclude that Michael Jordan jumped as high as 3.035 meters.
We hope that through our presentation you learned the physics aspects of Michael Jordan's free throw line dunk, from knowing the forces involved in the application of his third law and defining the height and time for a particle model.
Overall, analyzing Michael Jordan's free throw line dunk and the complexity that went behind it taught us the importance of physics in sports and how modern day athletes can be optimized if implementing the proper techniques of dynamics and physics.
Gang, gang.